Hello everyone, and thanks for joining me today. My name's Steve Button. I'm a product manager in the WebLogic server product management team, and today I'm pretty excited to be doing one of the first public discussions of a soon-to-be released product, Oracle WebLogic Server 12.1.3. In this session today, I hope to be able to elaborate and talk to you about some of the interesting new features we have that are of particular interest to developers working in the Java EE space. This is our safe harbor statement. Because I'm going to be speaking today about a product that's to be released and it's not yet publicly available, this information is particularly important to read. Okay, with that out of the road, let's have a look at the agenda for today's talk. I'm going to cover a couple of different areas. First off today, I'd like to talk about WebLogic Server 12.1.2 and just do a brief recap on the currently available production release we have of WebLogic Server. I'll then look at some of the new features and capabilities we have as part of WebLogic Server 12.1.3 and particularly how they relate to people doing development. I'll then look at how some of those new features we've added can be useful for supporting the development of back-end services for mobile and rich clients. And then finally I'll conclude with a brief touching on the REST management API updates we've performed inside the product. Let's get started. So here we have a feature snapshot of the WebLogic Server 12.1.2 release that's currently available. As you can see, this product release has got a vast array of features and capabilities that it provides. They encompass all of the sorts of things that you'd expect to see from true enterprise level and enterprise quality products around dynamic clustering, JMS, transaction logs, etc. Looking at management and monitoring through Enterprise Manager, caching and dynamic grid creation through coherence, working in cloud and working on virtual appliances, etc. We've also got some great integration features for working with the Oracle Database 12c through our Active Grid Link for rack capability, our multi-tenant database integration, our application continuity features, etc. But we've also got a number of features that are particularly oriented around supporting developers working with WebLogic Server. If we take a little bit of a look at those now, some of the things we've got in this release is obviously it's a carry-on from our prior WebLogic Server 12.1.1 release, which was our first release we put out that was conformant with the Java EE6 specification. So WebLogic Server 12.1.2 carries that forward. We've got the maturity around WebLogic Server with full support for Java EE6. To help support developers, we've got a zip file distribution, meaning you can download a zip file under 200 megabytes for a full WebLogic server, unzip it, run a script, and it's ready to go. As part of 12.1.2, we also provided some increased Maven support, and I'll touch on that in a little later on. We've also provided support with an implementation of the WebSocket protocol, so that gives us a listener that's capable of handling and working with clients, exchanging messages over the WebSocket protocol. And we also provided an API to allow developers to program applications to consume and use this WebSocket support. We provided Toplink data services, which was a very innovative feature from our JPA team for providing an easy way to expose entities and data sets to clients over REST interfaces. We added support for something we call a coherence grid archive, which is again quite innovative from the coherence team, which enabled us to essentially package up all of the artifacts and elements required for your typical sorts of coherence domain models, your listeners, etc., and deploy that as a unit to WebLogic Server, which could then instantiate and run them in a coherence cache. And we also touched on a new feature that enables us to leverage and use some OSGI capabilities from within applications that are deployed and running on WebLogic Server. Of particular interest to this session as we move forward was that 12c, or the 12.1.2 release, was the first release we provided support for working with the WebSocket protocol. So as I mentioned previously, this is an implementation of the WebSocket protocol directly and natively inside WebLogic Server, and we provided our own WebLogic Server API to enable customers and developers to build applications to use WebSockets as a transport. We've also provided support for JAX-RS, so creating RESTful services using the Java standard and deploy them to WebLogic Server. And as I mentioned too, we have Toplink data services, which pretty much provides us with a way to give access to data over RESTful interfaces with little to no programming on top of your JPA data model. And of course, those things can be consumed by all of the sorts of clients that are really starting to take off in the industry these days, be they the rich clients through HTML5 and JavaScript using any of the known frameworks out there, direct REST clients supporting mobile SDKs, etc. And of course to the new ADF platform that we have out there for mobile development. This is what we were able to provide with Toplink data services in 12.1.2, and just to call out a key point here is essentially what we aim to do here is provide a declarative way that's very easy to allow existing JPA data models to be exposed to clients utilizing REST interfaces that are generated automatically by the container, giving you consistency, giving us the ability to expose queries, things of that nature. Instead of me talking at length, what I'd like to do here is actually recommend, or very highly recommend, that you hunt down a talk by Sean Smith, one of the product managers in the Eclipse Link team, and he has a talk out there that was called Practical RESTful Persistence. It's available for replay on Parley's. Sean delivered this at the DevOps conference recently, and it's a really excellent session that sort of illustrates really what the power is with Toplink data services. The slides themselves are available on SlideShare as well, so that's another great place to go and have a look. But Sean really articulates the value that we have for Toplink data services and why it's such an interesting feature for developers to take use of in order to very easily and rapidly expose in a very consistent manner RESTful services over their data models. Anyway, go and check it out. Sean's a great speaker. His offsider, Doug Clark, has also delivered a very similar paper, I believe, at Open World and Java last year, so that may also be another avenue to try and get hold of the information. Last thing I'll touch on in 12.1.2 was sort of our Maven new capability. So really what we did in this release was realize that it's important for us to provide the WebLogic server libraries, APIs, clients, and more broadly speaking, the sort of whole of the Oracle Java environments through ADF, coherence, etc., and make those Maven enabled in a sense that we can take the libraries from an Oracle WebLogic server installation, from a JDeveloper installation, from an ADF install, etc., and materialize or push those libraries up to a Maven repository to enable developers to consume and use them in their own projects. So that gives essentially a standard set of coordinates for the Oracle libraries that you as developers can consume and use. So 12.1.2 was where we first supported that, and the way that worked, as I've talked about on one of these sessions previously, is we essentially provide a new plugin that will take libraries and take some descriptor files, etc., from an installation and push that to a specified Maven repository for you to use. So again, a new feature in 12.1.2 that really helped WebLogic Server and I guess the Oracle Java stack work more tightly in a more aligned fashion with standard Maven practices. And finally, just on that, we've also got some new documentation out for the 12.1.2 release that sort of talked about how you can construct and build out a continuous integration environment utilizing SCMs, utilizing continuous integration servers, utilizing our Maven capabilities, etc. So again, part of the doc set, well worth taking a look at when you've got an opportunity. Alright, now let's get on to the meat and potatoes of this talk, which is going to be about really what's of interest in the 12.1.3 release for developers, really what's new, what's coming. And as I mentioned earlier on, I'm one of the first people to be able to speak about this in a really public sense, so it's quite exciting for us to be able to speak about the product in this way now, knowing that it's not that far off. Alright, so what have we done? So as I've already mentioned, WebLogic Server 12.1.2 provided full platform support for Java EE6. So what we've done with 12.1.3 is provided some targeted updates to provide new or updated specifications that we get quite a lot of requests for, and as you can see here, they've popped up in the yellow boxes. That involves, in this case, providing an update to the JAX-RS support. So as of this release, we'll be providing support for JAX-RS 2.0 based on the Jersey implementation. And we're also providing a way to upgrade, support and use the JPA 2.1 specification through Eclipse Link 2.5. So those two things will be able to be enabled on your WebLogic Server 12.1.3 installation if you desire. Additionally, we've also provided support for the Java API for WebSockets. So this is a new standard API that has been developed under the Java Community Program, included as part of Java EE7, but we've been able to incorporate it and integrate it with WebLogic Server 12.1.3, so we can provide some early support for that. We've also provided another small API that was part of Java EE7, and that's the Java API for JSON processing. So again, just a fairly small library included as a default module with WebLogic Server now that enables developers to create and read JSON objects from Java. We'll touch on that a little bit more later on. But anyway, there's some exciting new things that we've got coming in WebLogic Server 12.1.3 in terms of Java EE updates. In terms of the Maven support, so what we have here is really carrying on what we've done previously. So again, still providing the synchronization plugin, still providing the WebLogic Maven plugin itself to enable you to automate your build and deployment and resource construction operations from within a Maven project itself. But what we've been able to do in this release is further enhance the WebLogic Maven plugin through the addition of a new goal, and that's called WLST-Client. And what the WLST-Client goal will do is, for the very first time, effectively provide a remote WLST environment to enable you to execute the scripts that you use to configure resources, control services, etc. on WebLogic Server from a programmatic manner, and execute those things completely remotely from a WebLogic Server installation. So in the past, you typically needed, or always needed, a WebLogic Server installation in order to be able to execute WLST scripts. As of the 12.1.3 release, and through the use of this WLST client goal from Maven, we can now execute those scripts completely independently of a WebLogic Server installation. So now you can do your full life cycle from soup to nuts, working from Maven in terms of controlling, configuring, setting up resources, deploying applications and testing them, all from within the boundaries just of your local Maven environment. So again, it seems like a relatively small change, but it again sort of demonstrates that we're committed to Maven. We're looking at how we can enhance and broaden support within the product to enable it to be more widely used. And WLST has been a great achievement in this release. Alright, so there's some of the new things that are particularly relevant to developers. We've obviously got a lot more in the release around enhancing a dynamic cluster support and a whole raft of other things. But in terms of development aspects and capabilities, there's some of the things that we've just provided. What I'm now going to do is step through and look at how we can leverage some of those new capabilities that we've provided around REST support and WebSocket support, JSON support, etc., sort of within the boundaries or the sort of scope of developing for mobile and rich clients. So if we look at the world of rich client development through many of the frameworks that are out there that have evolved, through to people developing, utilizing, direct HTML5 and lots of JavaScript tricks and techniques, etc., to work with data coming from servers, and similarly for mobile applications built to the various device SDKs. As you start to look at some of those things and you realize those applications actually need to get data and interact with services to execute transactions and store information that has been observed, things out that happen in the real world, we start to see that what we're seeing here is these particular applications are looking very, very similar to what we'd seen with client-server architectures of the past. And by that, we have these client applications that are primarily responsible for laying out a user interface. They're responsible for handling user inputs. They're responsible for performing basic validations of data that's entered. for controlling the state of what's appearing on the client, etc. And so clients themselves have now started to evolve and handling that logic directly within the client itself. We now see, likewise on the back end, we have servers that are handling or responsible for providing access to data, access to the domain models, etc., providing business logic to ensure that access to data and insertion of data, etc., is done within the constraints of how the business wants to operate. So we really have two very discrete endpoints here. Clients that are purely working with what users are interacting with. We have servers that are providing, effectively services that are able to be called from these clients that give access to data, that are responsible for storing information, etc. And so by marrying these two different endpoints up, what we have is a client slash mobile experience that enables to not only provide rich services on the client, but also to fetch and work with data in an interactive manner. So we're really seeing that is, sort of an evolution of the client-server architecture of the past. With the new model, however, instead of being constrained to working within the network boundaries of a particular company or organization, etc., we're seeing that these things are proliferated across the internet and proliferated across numbers of businesses, etc. And you only have to look at the app stores and the Google Play stores to sort of really see the diversity of applications that are being built out there today. So, these things are naturally oriented towards running on the internet. And in this case, this client-server architecture that we're alluding to here, we really have the web itself, and more specifically the HTTP transport mechanisms, is the glue that's connecting the client-server, the applications running on the devices, and the back-end server resources. So that's important, and that naturally maps into some of the things we're going to do with JAX-RS, etc. on the products. The data that's exchanged between the servers and the clients is typically formulated around the use of JSON, or the JavaScript object notation model. So we see that is a very common platform being used here. And then if we start to drill down and we look at how the applications themselves are actually interfacing and working with these back-end systems, we've seen that the evolution of the REST model is really been uptaken in a very significant manner through these rich clients and mobile applications to enable them to perform, the create, replace, update, delete style operations that are working with back-end services. So as we're actually communicating with back-end services, we're following the REST principles to provide, intelligent, predictable, lightweight access to the data over those services. We're also starting to see some uptake, and certainly a lot of interest from the way we've been able to measure it so far, in the use of the emerging WebSocket protocol, which really provides us with a bidirectional, one-to-one connection between a client and a server that enables the connections to take place in real time, clients to send messages to server to send messages to client, which is really interesting when we want to provide highly interactive, very current information to our client devices in order to provide, a very rich user experience. And so when we look across these things, we look at HTTP and web and business logic, persistence, etc. We look at REST exposing services. We look at the WebSocket capabilities. If we step back from that and we look at it, we say that actually the Java EE platform itself is an ideal place to actually build out and enable these back-end services, because a lot of the technology, a lot of the capabilities have been built right into the Java EE platform itself and the various products that are out there that implement and support it. So let's now take a look at what that means. So if we're looking at that landscape, we're looking at rich clients, we're looking at mobile applications, then overall the Java EE environment provides very strong capabilities here, all the way from the back-end persistence models through JPA and dealing with offloaded messages through queues, etc., through JMS. Business logic wrapped up with EJBs. We're utilizing the new capabilities to enable, highly interactive, highly scoped development through the use of CDI. So those existing mature boundaries we have within Java EE. But then we start to look at how we're actually exposing and making that information available to the outside world. In this case, we've got our mobile devices. We've also got our rich clients through HTML5 and JavaScript. And the services and APIs that we particularly expose and think are useful there are the JAX-RS specification, so providing a standard API for creating RESTful services in Java. We've got the new Java API for WebSockets, so how can I actually create applications, run them on my Java platform that can expose WebSocket endpoints to enable bidirectional connections to be established with clients. We've got the Java API for JSON to enable me to create and consume JSON objects when working with my business logic and back-end services. And so by putting this all together, I really have a complete platform that enables me to build back-end services that can then be consumed by these different types of mobile and rich client devices. If we translate that broad and abstract view into WebLogic Server 12.1.3, you can see that we've got a very good foundation for actually providing support for these mobile and rich application environments. So we're looking at the release 12.1.3 itself, by our support through JAX-RS 2.0 and its bonus, as I'll touch on a little bit later on, capability for producing and issuing service and events, through our implementation and integration of the WebSocket implementation, Project Tyrus, give us a true standard API for developing WebSockets. We've added something that the new capability here, which is a WebSocket emulation capability to enable us to support the development of WebSocket enabled applications on clients and servers, and then through the emulation layer we have and through a client library to transparently to a developer handle situations where WebSockets can't be supported in the browser or through various network infrastructure pieces along the way. The JSON programming API was supported, the Toplink data services we have within the product. Looking at it in conjunction as a product release, you can see that we provide very good support for this emerging world of building back-end services for mobile and rich applications. If we then look at some of the other capabilities we have across the Oracle Red Stack here, through our technologies we have in Oracle Traffic Director, and through our WebLogic plugin for Apache and soon to be Oracle HTTP server, we provide support for handling WebSocket protocol exchanges. So our front-end proxies, our web tier technology is being upgraded to fully support WebSocket exchanges that need to happen on front-end web tier infrastructure. So you can see that WebSockets themselves, these new capabilities, are not only being delivered as part of WebLogic Server, but also as part of our broader Oracle middleware portfolio through our web tier here. And of course, these really help expose these services to clients that can consume them, be they HTML5 clients, be they mobile SDK clients for the iOS or the Android devices, or even the new ADF mobile technology that we have out there. So we have broad capabilities here coming in 12.1.3 that can really help support development of these back-end services. All right, let's take a little bit of a look now at some of the specifics that we've added to the product in terms of these new specifications. So JAX-RS has been a specification that was part of Java EE6, definitely part of Java EE7, and really what it lets us do is provide a standard annotation-based API that helps developers, you guys, build RESTful services in Java. So it gives us a mechanism to take our Java classes, our Java objects once they're materialized, and expose them in a HTTP-centric way. So it essentially maps HTTP requests, be they GETs or POSTs, etc., through to actually invocation of Java methods on the back end. One of the nice things about JAX-RS is that it's POJO-based, so it literally uses a series of annotations that you can actually declare on your classes and on your methods that dictate to the container how I want to expose this to the HTTP world, and similarly which information I want to take from the HTTP world and make available to my POJO when it executes. So passing in path parameters and query parameters, etc. So providing the information I need to make sensible decisions inside my logic that I'm exposing as a RESTful service. This is an example of JAX-RS, and here we have just a plain old Java class, a POJO, that is called the ATM service. So it's simulating essentially an ATM service. And what we've done is we've provided a number of annotations here that declare to the JAX-RS runtime how I want to expose this to the HTTP world. So the first one that's interesting is the @path annotation, and this declares essentially the HTTP namespace by which I'm going to be able to access this service. And in this case, I'm using /ATM, and then I'm actually expecting another URI parameter to be passed through here called card ID. And I'm able to declare in this sense a placeholder. So as the JAX-RS container receives this HTTP request, it'll pull out that card ID and use it wherever I then declare it, and as part of my POJO here. So that's what I use to actually go ahead and make this class declared and usable, exposed to the JAX-RS world. I then have a method here called balance, and you can see that I'm actually annotating this with an @get, so that exposes this to the HTTP GET operation. I've further got a path, so this will be accessible within the /ATM/card ID, further by utilizing a /balance URI. So that's how I specifically reference this particular method. You can see that we have then annotated the fact that it's going to produce a content type of text plain as a response. And then interestingly, in the method declaration itself, I have a couple of parameters, a string that represents the card and a string that represents the PIN. But what I have here is a declaration to say that I want to fill those with values that come from various aspects of the HTTP request that's come through. So for the card parameter, I want to fill that with the path parameter card ID that I referenced above. And then for the PIN parameter, I've actually said that has to come from a query parameter with a name PIN. So here we'll have those values injected into my method variables, which I can then go ahead and use. So again, very simple. You can see it's very declarative, annotation based. If you remember the old days of servlet programming, I would be working a lot here with HTTP servlet requests, etc., and getting parameters and getting parameter values, etc. We've now evolved the platform to the state that those things can be discovered or declared as being required. The actual value extraction is handled by the container itself, and then it injects those values or supplies those values to my class when it's executing. Here's a further example where I'm issuing a post request. So in this case, I'm actually getting a HTTP post. So I'm pushing some data through. Typically a post interaction is defined to work with something that's going to insert a record or perform a change on the back end, since we only want it to happen once. In this case, I'm going to execute a withdrawal. And again, I'm passing through a path param and a query param through to my method. But in this case, you can see that I'm actually expecting to receive content type of text plain, but what I'm going to produce as an outcome is content that's of application JSON type. So the expectation is the client can handle application JSON as a MIME type and work with that data. So there we have a get and a post. WebLogic Server 12.1.3 has support for JAX-RS, so by default we'll provide the JAX-RS 1.1 runtime and API, so that conforms to the Java EE6 standard. But then what we're also going to do in this release is provide an optional shared library that can be deployed, which provides the JAX-RS 2.0 API and the Jersey 2.5.1 implementation, and that can then be consumed and used by applications that wish to make use of JAX-RS 2.0. Some of the things that we have in JAX-RS 2.0 that are of interest are things such as it's providing a new standard client API, so a very widely requested feature in fact, to provide and standardize this, providing filters and interceptors, some async processing capabilities, etc. So it's a very good evolution of the JAX-RS specification, and as a WebLogic Server 12.1.3 you'll be able to use it. Here's a quick example of the client API. Again, it's a very fluent API, very consistent with what we have on the back-end services. In this case, I'm actually setting properties that I want to pass through to my back-end service. So I'm specifying the card ID, the PIN. I'm telling it my accept type, and I'm going to go ahead and execute the balance method on the back-end service. So again, just providing the capabilities to build clients to consume JAX-RS services, be they standalone or be they other applications deployed to WebLogic or to your Java EE container generally. One of the bonuses we get from upgrading to JAX-RS 2.0 and Jersey 2.5.1 is service and event support. So this again is something that's not part of the JAX-RS 2.0 standard. It's something provided through the Jersey 2.5 implementation with an additional library there. And as part of that, that shared library that you can deploy on a WebLogic server, you have the capability to go ahead and use service and events. So all a service and event is really the ability to stream events in an asynchronous fashion from a client to a server over a HTTP protocol. So we establish one connection from a client to the server, and the server is then free to deliver as many messages over that single retained connection as it possibly can, or as it needs to. The API for using service and events on with JAX-RS 2.0 and Jersey 2.5 is fairly simple. We have an outbound event, we have an event output which represents a connection, and then we have a broadcaster capability. So it's where I can aggregate all of my connections and send messages to them with one simple method call. Here's an example of what a service and event looks like when running. So here we have, once again, it's very JAX-RS oriented. I'm describing a path for my service and event access point. I define methods that I want to expose using standard JAX-RS APIs and annotations. In this case, I've got a get to list the items. Where it starts to get interesting is where I can actually provide subscription services or subscription points for clients to come in and request access to one of these service and event streams. So here, once again, JAX-RS based. Of note is that this is actually going to produce, and here we're using a static that's defined in the SSE feature itself, but I'm going to return a content type of supporting the service and event model. In this case here, we're actually going to capture what we call an event output. So an event output is just a way of actually going ahead and representing that client connection, and I'm adding it through to the broadcaster. This is an example that comes from the JAX-RS 2.0 sample set. So I add that connection for that unique client through to my broadcaster, and then in a final method here, we can go ahead. It's a post operation, so again, from the client, they can issue a RESTful call, initiate a post. In this case, I'm expecting a standard HTTP form parameter to come through with a name. I go ahead and add that to a store here, so it's essentially an item. And then I issue two event broadcasts. The first one is an unnamed event, just basically to say, here's the new item that was added. And then I create a specialized named event type called size that I send back to my clients. And with the name on an event, clients working in the JavaScript event source in my browsers can actually subscribe and listen to specific event types. This is an example of the JavaScript you'd see in the client. And what we'll see here is that I can actually go ahead and create a new event source. It's passing it through my JAX-RS namespace for this particular application. And then I can go ahead and create functions to handle messages that are received. And I can narrow that down specifically with source.addEventListener and tell it the name of the event that I'm interested in receiving at this point. So again, very usable, very comfortable for JAX-RS programmers, but it also now provides us the ability to not only just create REST interfaces that can be called from clients, but it also enables my REST service on the back end to start issuing real-time or events that are being issued from the back-end server and pushing them through to the clients in an async fashion. So very good example of what we get with JAX-RS 2.0 and Jersey with WebLogic Server 12.1.3. WebSockets. So WebSockets are a technology that's evolved over a number of years and finally has been effectively pushed through various standards bodies to the point where now it's starting to become a very accepted and a very widely available technology. So what it really gives us is the ability to create TCP-based connection channels that provide full duplex communication between clients and servers. So clients can send messages at any time to my server, and a server can send a message at any time through to my client, all messages. There's no restriction on request response type models. As I mentioned, it's becoming increasingly standards based, so through the WebSocket protocol and the IETF, so the RFC 6455 defines the protocol itself. Through the HTML5 community have defined a WebSocket API for creating clients that can work with these things, and particularly from JavaScript and browsers. And of course, the Java community is standardized around the WebSocket 1.0 API for Java. So that gives us the ability to create back-end server applications that can leverage and utilize WebSockets. If we just drill down briefly into the details of WebSocket support in Java, again, being very consistent with the way that development activities are occurring on the Java EE platform these days, it's an annotation-based API for taking plain old Java classes, marking them as WebSocket endpoints, and then enabling them to interact with messages that are coming in over WebSocket connections and to send messages back to clients that have been connected. All done in a very simple to understand, very lightweight way. This is part of Java EE7, it's part of Glassfish 4.0, and we will be delivering this in WebLogic Server 12.1.3. Here's a brief example of a WebSocket, very simple, your typical echo hello world style example. So as you can see, it's just a plain old Java class that is annotated with an annotation at server endpoint, which defines the URI by which this web service, this WebSocket can be accessed. I've then defined a method which I've annotated with that on message. That method takes in a string message, and in this case it's returning a string. So what happens is once this class is registered with the WebSocket runtime, it's been accessed by a client. As messages come through, they're routed through to the method by which I've actually annotated with the @on message. And by returning a string in this sense here, the WebSocket runtime will actually send that back to the client. So that's how I send that response back. You can see again, very simple, annotation based, able to handle different lifecycle events for on, open, on, close, on message, etc. Here's examples of how we can receive messages as I just showed. We've got the @on messages, so we can deal with getting text messages, we can get it partial text based on the data framing model, etc. I can also provide and implement a specific interface and add that to one of the session handlers. Gives me a bit more capability in terms of creating the applications conforming to interfaces. But again, you know, horses for courses, programmatically versus declaratively based with annotations. To send messages, again, there's really a couple of options here. I can either return a value from the on message method that's called, or I can actually programmatically use the remote endpoint interface that we get from the WebSocket session that's established to get a connection endpoint to the client and issue a send text, send byte, send, etc. Method to send the data back to the connected client. As you would expect, I can send messages to multiple clients. So in this case, from my session object, I could actually get a list of all the currently open sessions for this specific WebSocket endpoint. I can check to see if that session is open, and if it is, then I can go ahead and issue a message by calling the send text on it. So that way I just iterate over the set of open connections and send them the same message. So effectively issuing a broadcast. There's, as we said, different ways to actually go ahead and receive messages through the @on message annotation. We can, to handle the various lifecycle events that are occurring within the WebSocket runtime, we can actually use annotations, so @on open, on message, etc. Or I can actually create programmatic endpoints by implementing a specific javax.websocket.endpoint interface and specifically creating methods that conform to that interface, which will then be called back. So various different ways of doing, of developing WebSocket capable applications. I mentioned earlier on that we have WebLogic Server 12.1.2 had its own WebSocket API. WebLogic Server 12.1.3 is going to have support for the standard WebSocket 1.0 API, and really this is sort of a list of the differences. Primarily driven about by 12.1.3 supporting or integrating the project Tyrus, so the reference implementation of the WebSocket 1.0 API, and then supporting that actual WebSocket API itself. So there's a number of differences in the way here we actually handle stuff. Moving forward, obviously the WebSocket 1.0 API is where development and new activity should occur, but we'll continue to support the 12.1.2 WebLogic WebSocket interface, for several releases into the future, just to maintain backwards compatibility. We've done some really good, benchmarking internally, of course, in informal fashions to really look at the scalability and performance numbers we can get. And we've been very, very, very pleased with the figures we're getting back from these tests that are showing that we can really scale up and support large numbers of connections on a single WebLogic server instance. So yeah, really good stuff happening there, and that has carried forward from both the 12.1.2 release with a WebSocket native, WebLogic server native implementation, and now through obviously to the Tyrus-based implementation on WebLogic. All right, finally, we've talked about Happy HTML5, we looked at WebSockets. It's all really good, great, exciting opportunity for creating new applications, but unfortunately, not across the universe is WebSocket supported in exactly the same way. So most browsers have very good current support for HTML5 and WebSockets, but not all of them. Some cases, firewalls, proxy servers can block, the frames, the protocol, etc. So what we've done in 12.1.3 is provided a WebSocket emulation capability, which as developers lets you build to the standard WebSocket API in the back end, the standard JavaScript WebSocket clients, and then not have to worry about what's going to happen at runtime. You're building WebSocket applications, and under the covers, with the WebSocket emulation capability we have on WebLogic Server, and with a small client library that you can actually bundle and use, or bundle and call, we will handle under the covers the fallback from a WebSocket protocol down to a HTTP long polling model. But as far as you're concerned as a developer, you're still working at the WebSocket layer with data frames, etc. This is an example of what it looks like. As you can see, on the client side, again, just using pure WebSocket JavaScript objects. All I'm doing is including our RSocket client library. On the back end, I'm working to the WebSocket API. At runtime, these two things come together. They'll negotiate. If a WebSocket protocol connection can be established, great. If not, it'll degrade down to a HTTP long polling, and we're looking at supporting other protocols into the future. Java API for JSON processing. This is something that we've pulled in. It's a very small library, pretty much just gives us a way to create and work with JSON from a Java world. This is an example of what it looks like. Again, very simple, creating an object, adding some elements to it, some property types, and then calling a build on it. So again, a fluent API that lets me create JSON objects. All right, finally, time's short. Thanks for staying with me. The last thing I want to talk about WebLogic Server 12.1.3 is the innovations we've done around our REST management API. So in 12.1.2, we had a REST management API that let us effectively do a whole bunch of gets. So that conformed to essentially a monitoring model for working with WebLogic Server from a RESTful API perspective. From 12.1.3, we've now provided some significant updates to that API that now lets us actually execute post operations. So I can now do some resource configuration, some server lifecycle management, application deployments from the REST API. So this is really going to let us build out new rich clients, expose the management capabilities of WebLogic Server to a whole raft of different clients, be they mobile devices, be they HTML5 JavaScript clients using Angular or Bootstrap, etc., PHP clients, terminal clients, etc. So really just exposing essentially the guts of WebLogic and its management API through REST APIs. So very good advance for the product. All right, so sorry, a bit of a rushed end to that, more slides than I thought I had there. But thanks for staying with us. WebLogic Server 12.3, very, very interesting release. Lots of new stuff for developers, lots of innovation happening around the product in general, but new APIs through JSON and WebSockets and conforming to standards, etc. If you want some more info about any of this stuff, about WebSockets, JSON, things like that, Riza Rahman, one of our Java EE evangelists, is a great resource. We've got the Oracle WebLogic Server Twitter feed, our blog site, our OTN page. If you look on the JCP organizations, you can find access to the specs. So anyway, thanks very much for listening.